God. Supernova, I go buy you things from Fashion Nova. I don't go do you Jungle Nova.
Hello, everybody. My name is Belcher Sebastian. I'm here at Arizona State University Geotechnical Engineering Lab. Today, we're going to go over lab number 3, which is the Atterberg Limits. So during this lab, we're going to be able to determine the liquid limit, plastic limit, and the plasticity index of the soil, as well as this USCS classification of a fine-grained soil sample that we're going to be using. And also, we're going to be able to determine the liquidity index and the degree of saturation of the soil used during the lab. Well, it is really important to know the liquid limit of the soil, because this is what's going to define the strength of the soil. And also, we know that as the liquid limit goes up, the grain size of the soil, it tends to go down. Well, pretty much liquid limit is the water content at which a cut made in the middle of the soil is going to close with 25 blows. And then the plastic limit is pretty much the water content at which the soil, once we begin to roll in the soil, this is going to crack and crumble at a diameter of 3 millimeters. First one that we have here is our mixing bowl. This is what I want to mix the soil. This is the sieve that we're going to be using to sieve the soil. This is the sieve. It has to pass sieve number 40. This is the soil that we're going to be using. This is the beam to take all the moisture content cans to the oven. These are the 5 cans for the liquid limit test. These are the 3 for the plastic limit test. This is the Casa Grande device that we're going to be using to do the blow counts. This is the groove that we're going to be using to make the cut in the middle and also to adjust the point and the position of the device. This is our roller, like 3 millimeters, the one we're going to be using to know the exact size where the plastic limit is going to happen. This is the water that we're going to be using. This is the glass that we're going to be using to roll the soil until the grain for the plastic limit. And finally, we have the soil. This is the soil that we're going to be using. It's not sieved yet. We're going to sieve to pass the number 40, but this is pretty much the soil that we're going to be using. Well, in order to calibrate the drop height, we're going to be using the end of the grooving tool, which is pretty much 10 millimeters, and then we are going to adjust until to the point that when we do one blow, it doesn't lift it up, the top part. It's just pretty much just touch the top of the grooving tool without lifting up. So that's pretty much what we're trying to do right now, and at that point we just get it. If you see, there is no lifting anymore, so that's the right point. So pretty much here we're trying to add water into the soil so we can get the peanut butter consistency, which is pretty much roughly 40 blows. So that's pretty much, we want to start with the highest number of blows, and then we go down to the lowest one by adding water. That's pretty much our goal, and then we're gonna see as we put it down. So now we just adding our soil into the device, and we expect that this soil is gonna take us at least 40 blows, because we need numbers from 10, 20, 40s. So we want to start at the highest, number of blow, which means the driest, so we can just add water, because we cannot do the opposite. We cannot add soil if it is too wet. So let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So pretty much it ends in the 10th. So that's just something that we needed. But still, we're not going to waste the soil. We're going to take a little bit of the sample and then do the water content. And then before we do the water content analysis, we're going to weigh the can with the moist soil in it. And then we're going to take the measurement of that weight, And then now, since our sample is too wet, we cannot add dry soil. That's something that we cannot do. So we're gonna just play with the soil, use our hands, so we can just lose some water content as we go along. And then because since I started at 10s, I expect my next sample to be in the range of 20, and then I'm gonna play a little bit more to be in the 30s and the 40s. But we cannot add dry soil. That's wrong. So we just need to use our hands to absorb most of the water content. So that's pretty much we expect from the next one. Well, okay. Now we just played with the soil. So we expect this one to be a higher number of blows since we kind of reduce the amount of water content. That's our expectation, and then we're gonna start a new one right now, and then we're gonna see how it's gonna be. Just like here, we're just making the cut pretty much. This is what we are doing right now, and then let's see how many blows we can get this time. So let's see, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Well, now as we can see, now we got a number of blows up to 20s. So we're going to do the same procedure again. We're going to play with the soil so we can get the number of blows up to 30s and then 40s again. So that's pretty much the procedure that we're going to do until we finish all the sampling. Well, now pretty much we're going to just repeat the same procedure so we can get the blow count in the range of 10, 20s, 30s, and 40s. So we can now interpolate and then find the number 25, which is pretty much the number of blows that correspond to the liquid limit of the soil. So pretty much you just do the same procedure again. You do the number of blows, you record the number of blows, and then do the water content analysis of that sample as you go along until you complete all the procedures. So pretty much here, when it comes to the plastic limit, we're pretty much going to just be rolling a sample of soil. And then we're just looking for that moment when it starts breaking, when it begins to break or like crumble a little bit at the same size of the piece of metal that we have in there. So pretty much that's where the plastic limit is gonna happen. So if it start breaking before, is because it is too dry. If breaks right after passing that diameter, is pretty much it's too wet. So we need to work on the soil and do the same thing. If it is too dry, we can add water. If it is too wet, we need to play with the soil with our hands so it can absorb some water. Remember, do not add dry soil, never. So pretty much we keep doing that, and then pretty much in there we found the plastic limit is kind of pretty much the same size. And then after that we do the water content analysis. We weigh the can with the moist soil, and then we repeat the same procedure for the other 3 samples. So pretty much in here we have finished doing all the tests. We have the plastic limit and the liquid limit test. Once we have them all, we're gonna place them into the oven so we can just do the water content analysis. So they're gonna be there for 24 hours. So pretty much the next day we're gonna come back to weigh the samples. So pretty much after 24 hours, here we are. We just come into the lab, right? We're just coming and then weigh the dry samples so we can do the water content analysis, and then we can just calculate the weight. Once we know the weight before and after, pretty much the moist weight and the dry weight of the soil, we can do the water content analysis, and then we can pretty much answer all the questions in the lab, because these are pretty much the liquid limit and the plastic limit we are looking for this lab pretty much.